Hi, welcome back. I just to give you an update, what happened to me. About in February, I went for a stent to be put in on my left carotid artery because a year and a half ago I had a stroke due to a blockage in my right carotid artery. So I wanted to make sure that didn't happen again. As a result of that operation, though, I had to take some medicines that were blood thinners. And what that actually did to me, I had some internal bleeding, and it had lowered my blood count significantly. So I was able to go to the hospital. They were able to take me in Biddeford. I had an examination. They gave me transfusion a couple of times, a couple of units. I feel much better now. I'm back to normal blood count, but I'm afraid I missed a couple of sessions for you. So I just want to go over in a nutshell what what was supposed to have happened Tuesday and Wednesday. Okay, so we started out with chapter 7, which is flip flops, and the idea here, the important idea is to understand in flip flops is the latching process. But basically, uh, digital processes occur by transferring data to the proper places so that things can happen. So the only way to do that in a timing process is to make sure that data is uh, placed into uh, memory for short periods. Timing is of the essence. In other words, everything happens in time. Number step one, you want this to happen. Step two, this other thing to happen. Those all happen in time. So the timing is very important. But in the meantime, also, you need to make measurements. Measurements have to be recorded and used for later use. So we come up with flip flops that can actually cause temporary uh, uh, temporary storage of memory items. Now, what's important so is the latching process. Latching means that locks that data in place for a specific amount of time. The other important part of that is a triggering process, which actually lets you progress. Okay, and there are two ways of triggering things. Mainly, when there's either a positive or a negative going signal on your square wave, and that's what actually causes the something to happen. Okay. Then, following chapter 7, we went to chapter 8, which is concerned with counting. Counting is very important because it's the way if you're going to do time things, you have to have a certain amount of time. And so, how do you get that time interval? You count them, okay? And we have two different ways of doing that. We can use ripple counters and we can use synchronous counters. The synchronous counters depend on a clock signal. The ripple counter actually uh, depends on the input of the data. Okay. And the most important of those particular components is the JK flip-flop, which allows you to toggle everything so that the data can progress uh, and give you a good method of counting. We also give some application or examples, a lot of examples of the applications where we use these things, and those are all very interesting. I hope you all read about that. And then finally, chapter 9, shift registers. Well, the shift registers, what the shift registers are all about is moving data. How do we actually move the data? The data, as we know, is in the digital format is a bunch of zeros and ones, and we call those strings of zeros and ones. Okay, how do we move that data around so that we can use it? We use shift registers, which means that we take the data and move it from one area to another. Okay, we can do that. We can do that in a number of ways, two different ways. When we shift, when we can shift data digitally, we can do it by a serial method, or we can do it as a parallel method. Serial method means that you're just snaking through the information one digit at a time, one bit at a time. Parallel method is when you take a byte of information at a time and in a parallel situation, and you plug it in to the register, and we do that in time-wise. So that's basically a catch-up on that. So I hope you all got a good chance of reviewing the lessons and reading the different chapters, going through the homeworks. If you have any problems, understanding anything, I'm here to help you out. But I hope it was successful. Today, we're going to have our last lesson. Okay, the last lesson is something that I thought you should have. It's basically an add-on from when we started to yesterday. We learned about the different components that are used in digital electronics. Now today we're giving a leap forward, and we're saying, look, digital electronics is basically a computerized system. Okay, and that's in everything and most of the equipment that we use today. So this is good, looking into the actual things as they are in modern time. Okay, cars have it, refrigerators have it, all of our cell phones have it. Okay, use it. And so this is an overview of what happens when you have an actual digital system. I hope you get something from it. I hope you get a better understanding of how digital systems actually work. I use the example that I did when I taught a course in microcontroller to some people at where I worked at. Microcontroller means that there's a small microprocessor that handles all the data information. The function of the microprocessor is to process data. Okay? It receives data, so it needs to know where's the data coming from, what kind of data it is, and where does it need to go to get utilized. Okay, that's the rest of the circuits in the microcontroller unit that handles sensors, it handles messages, communications, a whole bunch of other things. And it has separate places where that information comes in. Information comes in a number of different points, which we call ports. And they put this, so the data is imported into these individual ports. Each port is designed to accept certain types of data, whether it be numeric data, whether it be informational data, okay, or timing data. And Also be aware that there might be an interrupt. In other words, something that comes in that all of a sudden has to interrupt whatever the process is doing, so that it's an important message that has to be recognized. So there are different ports that do different things, and I hope I explained some of that in the presentation that you have for today. Have fun with it, okay? It's basically an overview, and I hope some of you will someday try to learn a little bit more about it, okay? But tomorrow is going to be the exam day. It's your final exam. It's your really final exam. I know you'll all do well, but to prepare you better, I'm also um, handing you a review of last week's and this week's information. As I mentioned also, the exam will be very different than what you've had in the past. Okay, it'll be a summary exam. Okay, I'm looking forward to, I'm looking at what have you learned, what does it mean to you, and how can we get better? Okay, those are the type of things I'm really interested in as your final exam. It's an important subject. Okay, so good luck, have fun, and I'm sure you'll do well. And if you have any questions at all, if you're curious about things, how things might operate, give me a call, email me, whatever, but I'm always available. So, ciao.